Welcome to the second lecture in Python chapter 2, which is Python revision 2.1. And in this lecture we are going to talk about the basics of Python. Firstly, we are going to talk about what is data types. In all programming language they have data types, and data types are the fundamentals or the basics of any programming language that we have to understand. So data type means what type of data that we are going to store. For example, the data can be name. When you think about name will be only letters. Okay, the letters is also known as string, right? Or in some other programming language it is known as characters. Okay, characters. And we also have numbers. For example, if you want to store phone numbers, it is number can be integer, which is without decimal point. Number can be true or false. True is represented as 1 and false is represented as 0. And we also have float means a number with a point, decimal point. And we also have complex number, right? String I have already explained, but here you have to remember that even numbers can also be stored as string. If you enclose with single quote or double quote, it become a string. Okay, we also have lists, we also have tuples, we also have dictionary. Please try to remember that in list it is square bracket, in tuple it is normal bracket, and in dictionary it is curly bracket. Okay, we are going to study this list tuples dictionary in the coming chapters. So if you don't understand clearly now, please don't worry. These are the core data types in Python. For example, we have number, we have none, we have sequence, we have mapping, and the different numbers are integer, floating point, complex, and under integer, the Booleans comes. Okay, the Booleans means 0 and 1, only binary number. And we also have none and no any none. N is capital. We have sequence. In sequence, we have string, we have tuple, we have list. We also have mapping, which is dictionary. All right. And now let's talk about mutable and immutable data types. The immutable types are those that cannot change their value. For example, tuple is one immutable data type. I can declare tuples like this. Tuple 1 equal to 1 to 3. And if I want to change the first letter 1 to 7, it will generate error. So it cannot be changed once you declare it. Whatever you declare, you have to use it. It is fixed. You cannot change. Those are known as immutable types. Okay, immutable. But there are mutable types. The value can be changed even after it is declared. For example, we have list, we have dictionary, we have sets. Okay, and for example, colors red, green, blue. If I want to change the value of the index number 1, which is the number 2 because it starts from 0, and that is green, I'm changing that green to yellow. There is no error. So if I print the color, I'll get red, yellow, blue because I already changed that green to yellow. These types, these are known as mutable data types. Now let's talk about expression. Expression in Python is any valid combinations of operators, literals, and variables. Expressions may be arithmetic expressions, string expression, relational expressions, logical and compound expressions. And the expressions have the different operators in any expressions can be evaluated based on this precedence or priority. Okay, this bracket will have the highest priority, and this and or not etc will have the lowest priority. Okay, and the lowest one, I don't know, it's not mentioned here, is usually the assignment operator. The equal to operator is the single equal to operator is always having the lowest precedence. Now let's talk about typecasting. Typecasting means conversion of uh, one data type to another. Okay, conversion of one data type to another. For example, if I divide 7.0 divided by 2, 7.0 is float, 2 is integer. Okay, here, yeah. 7a is 7, b is 3.0. So if I add this to a 7 plus b 3.0, and it is a mix of integer and float, what will be the result? What will be the data type for C? So it will become float. Okay, when we combine float and integer, it becomes float. But this is automatically done by the compiler. We don't need to care about it. But if you want to care about it, you can specifically convert by specifying the type where you want to convert. For example, a is 5.9 here, n equal to integer a. Integer a means we are going to extract the integer part, and it will simply display 5.9 will be discarded, and the type will be integer. We printed the type using the type function. All right, this is known as typecasting. We have implicit and we have explicit. When we say implicit, it is automatically done by the computer, but when we say explicit, it is specified by the programmer. I hope it's clear. Now let's quickly go through the different math function which is provided in Python and ready to use. But in order to use, please remember that you have to import this math. Okay, import math. If you are not specifying this, you will not be able to use it. Okay, sealing, right? Seal, it comes from seal You can give any number to be sealed. If I give met.seal within bracket 1.03, it will be sealed. It will go up to 2, right? It will go up to 2. If I say 1 minus 1.03, it will go up to minus 1. We have square root, we have exponential, we have square root. I hope you know, right? 8 to 1 square root is 9. And exponential means this will return e to the power. And fab, it is the absolute value. Okay, it will give the absolute value. Maths.fab1 will give 1. Maths with minus 1, fab minus 1 will give 1. No minus sign in fab. All the minus sign will be removed. And floor, the floor function return the largest integer greater than the number. For example, here 1.03, the floor will give 1, like that. Now let's go to the next slide. We still have the log function. We can find the log function. We can also find the log10 function. We can also find the power. Okay, if I say 3 to the power 0 will become 3, or 1 to the power 0 will become 1. Yes, 4 to the power 2 will become 2 to the power 4 to the power 2, and it will become 16. This is the power. Okay, and we also have, we can find the sine, we can find the cos, we can find the tan. Since this is not mathematics class, I'll not go deep inside this, but if you want to implement it, you can implement it easily. We have degree, we have radians, etc. All right, do you have any question?